So we just learned that anytime you have the natural log of a function and you want to take its derivative, it's always the derivative of the inside over the inside. And so I wanted to come to this example, and I'll warn you now, this example has a very clear moral to it. There's something I want you to walk away learning after we do this. So I'm going to work this out one way, then I'm going to work it out another way. And so solution one, I'm just going to dive right in. I'm going to use that previous formula without really thinking too much about the problem. Previous formula says derivative of the inside over the inside. So here we go. So y prime, I'm going to set this up. So I'm going to have an ultimate big fraction here, and I'm going to have g prime over g. So I'm going to have the inside on the bottom. I can go ahead and write that. There's just the bottom. And now I got to take the derivative of the inside. That's going to go on top. Going to have a quotient rule. Oh my. So I get the derivative of the top, which is a 1, times the bottom, x minus 2. I'm writing up here because I'm going to have another fraction over the bottom squared. So derivative of the top is 1 times the bottom minus the top times the derivative of the downstairs, which is 1 over 2 root x minus 2 times the derivative of the inside, which is a 1. All over, oh my goodness, all over the bottom squared. Well, thankfully, at least the square root goes away. We just get an x minus 2. So now I'm looking at this thinking, wow, first off, let's center this because that's not very nice. There we go. And now, I got to clean this up. This is just untenable. So I noticed that this fraction up here is just nasty. So let's maybe I'll do it in red. I'm going to multiply the top line by x minus 2, and I'm also going to multiply the bottom line by, let's say, x minus 2 over 1, and then I'm going to go over x minus 2 over 1. Okay? So that's what's happening here. X minus 2, if you want, you can think about it, you can think about it like this if that's helpful to you. So the 1 is going downstairs and x minus 2 is across the top. So let's really carefully do this. You got to be so careful not to mess anything up here. So when I distribute, these two cancel and I just get an x minus 2. That's nice. And then this one and this one cancel out. They're gone. And so I get minus a half times x plus 1. And then I've got this all over x minus 2. And then I've got this all over x plus 1. You can think of the x plus 1 as over 1, flip and multiply, and so you end up with x minus 2 minus x over 2 minus a half all over x minus 2 times x plus 1, because that's all you're doing. This just goes right there. If you're not sure about that, pause the video and check the algebra yourself. And so now I can write this as, well, let's see, this is going to be x minus, x minus x halves is going to give me positive x over 2, and then minus 5 halves, and then all over x minus 2, x plus 1, and finally the 2 downstairs, and both of these you could pull downstairs. I'm going to clean it up and write it as x minus 5 over 2, x minus 2, x plus 1. Oh my goodness. So kind of a long problem. I mean, the initial derivative, I guess, wasn't so bad, but it was pretty bad, actually, pretty hard. And then to simplify this down to a nice answer, which, by the way, it did simplify to a nice answer, but it took a lot of work to get there. So that's solution one. Solution one is you're using the formula that the derivative of the natural log of a function g is just g prime over g. And we use that without stopping and thinking about what we're doing at all. We just did it. I guess the point is it's always good to stop and think, because let's do a solution 2 now. Whoops. This is solution 1. Solution 2, and I'm going to stop and think when I do the second solution, and I'm going to realize, oh my goodness, I can simplify this function using the laws of logs before I take derivatives. And so let's go up and copy our function again. I'm going to copy this, and I'm going to pop it right here. And I realize, okay, just laws of logs, no calculus, no derivatives. This is not y prime, just y. I get an ln of x plus 1 minus ln of the square root of x minus 2, I can do even better. I get ln of x plus 1 minus a half ln of x minus 2. Wow, that is going to be significantly easier to differentiate. Here we go, one fell swoop, no simplifying required. Derivative of this part, the derivative of the inside is just 1 over x plus 1. That half tags along, so minus a half. The derivative of the inside is 1 over x minus 2. And if you took the time to find a common denominator and put those together, you could combine this like this one. These are in fact the same. You don't need to. Sometimes students are a little overzealous to combine fractions. It's perfectly great if you want to, but if there's no main reason to, then just leave it alone. So what's the moral of the story? See if you can answer that question before I tell you. The moral is simplify before you take derivatives. I'm going to say it again. Simplify before you take derivatives. Then after you simplified, this formula is really your friend, and it works out quite nicely. All right, so let's break this video here, and we'll do some more interesting things in the next one.